Hey everyone, welcome to your Play Posit for the week. Today we're going to do something a little bit different and we're just going to kind of catch up on the rest of our Unit 4 notes. This is going to take us through perimeter and area using the coordinate geometry, and so this is just finishing up our notes from last class. You want to go ahead and grab your notes from 11.3 from our live class. Those can be found in our OMHS course under content and live class notes. They're also on your plan for 11.3. Yes. So let's go ahead and pick up where we left off. If at any time you want to pause the recording, try these on your own and come back for the answer. That is perfect. And then of course, I'll build in some stops for you guys to try it on your own. So it asks us to find the area of a rectangle with these vertices. Remember that coordinate points go x, y, right? Alphabetical, and this is the x-axis, and the vertical is the y-axis. So we'll plot these points over 4 and 0, and then -3, 1, 0, -2, and -1, -3. And I know that we did some of this in class, but I thought we could just start here. So we do have a rectangle, but remember we can't find the length of the sides just by counting the units. Not unless it's on a straight grid mark can you just count the units. So in this time, we're going to have to use the distance formula. So I'm going to put it here. You just subtract the x values and subtract the y values. Square them, add them together, and take the square root. So I know this kind of looks like a long formula, but I promise the more that you write it, the more that you practice it, it's just going to become second nature. The x's go together and we subtract. The y's go together and we subtract. And then you square them and square root. All right, so let's give these points some labels. I'll call this A, B, C, and D. We'll label this A, B, C, and D. Okay. So let's find the distance between A and B. So once we label the points A and B, x1, y1, x2, y2, all we have to do now is plug those values into our formula. So we'll have -3 minus -4. We're going to use lots of parentheses so we don't mess up those negatives. And then 1 minus 0. Okay, remember you can use your calculator, but here a negative times a negative, that becomes a positive. So we have -3 plus 4. That's 1 plus 1, right? All right, 1 squared is 1. So we have the square root of 2. Now it's best practice, and it does tell you here, do not round any sides, to not round until the very end because we don't want to lose any of those decimal point values. Now if AB is root 2, then we also know that CD is root 2 because it's a rectangle, right? And we know opposite sides are congruent. So we only have to do the distance formula one more time. So let's find the distance between B and C. So now we can call this x1, y1, and x2, y2. All right, y2 is -2. I'm sorry. I just picked y2. Hold on. That came out of nowhere. Literally. Okay, x2. x2 is 0. x1 is -3. We have to have the minus in the formula and then also the actual value of x2. So, oops, x1, sorry. So don't lose the minus and the negatives. I was getting confused with this. There we go. All right, y2 is -2 and y1 is 1. Okay, there we go. Negative times negative, that's that positive again. So we'll have 3 squared plus -3 squared. So 3 squared is 9, and -3 squared is 9. Square root of 18. Both sides, right? Now it says to find the area. Area of a rectangle is length times width. So we're going to have root 2 times root 18. Oh gosh, this is going to be so much fun. Hold on, let me get a new slide. Root 2, root 18. Do you guys remember doing this in algebra? Hold on. Okay. If you had me, we did this a lot. So we're going to multiply square root of 2 times square root of 18. Reducing radicals. So at this point, you can likely take your calculator and get a decimal answer, but let's also do it by hand and get a radical answer. Now, when you're multiplying, you can literally just multiply. But let's reduce this radical first to see if that'll help a little bit. So remember, we can do our factor trees. Excuse me. We're looking for a perfect square within 18. So 2 times 9 is 18. Oh, there's our perfect square, right? Because 9 is 3 times 3. And remember, a perfect square is when you multiply it by itself. So we can write root 18 as square root of 9 times square root of 2. Now we can go ahead and take the square root of 9. So square root of 9 is 3. We have root 2 left over. Okay, now we just multiply the radicals and the numbers in front. They're kind of like coefficients. So 1 times 3 is 3. Root 2 times root 2 is root 4. Ooh, what's the square root of 4? Square root of 4 is 2. Bring the 2 out, and you get 6. 6 what? 6, it doesn't have units, so we're going to say 6 units squared. That was so cool. Did you guys see that? Let's try the calculator and see what we get. Root 2 times root 18. I'm just going to grab this one because I have it here. Let's see. Hold on. Root 2 times, let's see if this works. Root 18. I don't know if that's calculating 100% accurately. Hold on. Let's get our Desmos. Okay, I came to Desmos, and I think I accidentally typed 8 on the other calculator. So you can see root 2 times root 18 is 6, which is what we got when we did it by hand. That's so cool when something, you think it's going to be some weird decimal or radical and just works out perfectly. 6 units long, or 6 units squared. All right, let's try this one. What is the perimeter of the rectangle shown on the coordinate plane to the nearest tenth of a unit? So you can see it's not sitting directly on the grid mark lines, so we do need to use the distance formula again. So we can find from here to here, this is -4, 0, and 4, 4. So let's do that first. I'll write the formula up here again. And you should too. It's good practice to just write it out. I promise it'll come flying out of your brain the more that you write it. And let's plug them in. Oh, I like to label. X1, Y1, X2, Y2. All right, now 4 minus -4. And then 4 minus 0. So this becomes that positive. We'll have 8 squared plus 4 squared. So 64 plus 16. What is that? 80, square root of 80. Okay, so we'll leave this side square root of 80 and this side square root of 80. Now let's find the shorter side. I'm going to grab a different color. We can go to here if you want. It doesn't really matter whichever side. So this is -6, 4. And since I labeled this X1, Y1, I'm going to call this my new X2, Y2, just to keep it straight. All right, so -6 minus -4. We're really just plugging it into that formula. 4 minus 0. It's very close, isn't it? Oh, I didn't really need that one, but that's okay. All right, negative times a negative again is positive. -6 plus 4 is -2. And then we have just 4 squared. So -2 squared is a positive 4 plus 16. Square root of 20. Both sides. So it wants us to find the perimeter. So we have to add them up. Or remember, the perimeter of a rectangle is 2 times the length plus 2 times the width. So we could also do that. Let's do that. All right, so 2 times the length, 2 times root 80 plus 2 times root 20. There's a few ways we can do this. Because it asked for a tenth of a unit, I say we go ahead and just plug it in our calculator. We could reduce these radicals, but again, because it wants a tenth of a unit, we know we're going to have a decimal answer. So let's go to our Desmos. 2 root 80 times 2 root 20. All right. 2, and then square root of 80. Arrow out of that. See, if I was still under here, it stays under. Make sure you arrow out. Plus 2. It was 2 root 20 and 2 root 80, right? Yes. I have a very poor short-term memory. There we go. All right, so 26.8, right? This 3 will keep the 8 an 8. So 26.8 is to the 10th. Here's our answer, 26.8 units. Since we don't know the specific units like miles or inches, we're just going to say units. All right, what's the perimeter of the triangle shown on the coordinate plane? So perimeter, that's still the distance all the way around. And we have 3 sides, so we might have to do the distance formula 3 times. But, ooh, look, this one's right on the grid line, so we can count these. 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5, 6, 7. 7 units on this side. So we just need to do the distance formula twice. So from -3, 3 to 3, 4. x1, y1, x2, y2. Let's do it. So 3 minus -3 plus 4 minus 3. Remember, we subtract our x values and subtract our y values. This becomes a positive, and we get 9 squared plus 1 squared. 81 plus 1, root 82. All right. Now let's do the distance between the other two. This is 3, -3. Since I already called this x1, y1, I'll call this x2, y2. So we'll start with 3 minus -3 plus -3 minus 3. All these 3's. Careful. This is a positive, so you end up with 9. Nope. Do you see that? Look, I hope you guys caught this. 3 plus 3 is 6, you guys. My apologies. So this should be 36. So this should be root 37. Good catch, Miss Winslow. 6 squared. This will be a -6 squared. So we'll have 36 plus 36. What is that? 72. Root 72. Okay, now you find the perimeter. And it does, again, say the nearest tenth. So we'll just add them all up. Don't forget the 7. Root 37, root 72, and 7. Okay, let's see if I can remember all that. Root 37 plus root 72 plus 7. 21.6, right? The 6 will turn that 5 into a 6. We'll round that up. 21.6. units. So you can see so far all these problems, we're using the distance formula to find the lengths of the sides to do those calculations. I'm wondering if you guys are noticing a real world application of this. You're basically a human GPS. I mean, if you can imagine, these three coordinates here are three different places on a map. Maybe this is your home, and this is the store, and this is the doctor's office. And if you've ever in your life used or seen your learning coach use their GPS either on their car, their phone, maybe even the computer, and you've mapped out your route. I've done this before where I start at my house and I know I need to go to the doctor's office, but maybe I need to stop at the store first. Hopefully there's a store somewhere along this route, but maybe there's not. So we go here first and then here. And the GPS will automatically calculate the distance, which then plays a role into how fast you're driving and how long it's going to take. And all those calculations are built into the computer programming of the GPS. GPS programming uses the distance formula. It's a little bit different because we're working with like three-dimensional life, So they actually use satellites and use three coordinates. They'll use latitude, longitude, mostly latitude and longitude, but they'll also find that third coordinate from space. It's really cool. Talk to you guys about it all day long. I'm not a GPS expert or a coding expert, but I do love the application of what we're studying. That part I love. What is the area of a parallelogram whose vertices are this? All right, let's plot it. Negative 12, 2. Whoa, these are really tiny. I know I had to give you a big grid because there's so many, the coordinates are so large. 6, 2, negative 2, negative 3, and negative 20, negative 3. Okay. Ugh. I don't trust myself, so I'm going to get a straight edge. Come on, PowerPoint. Here we go. If it's going to let me. Nope. Hold on. Yes. Ta-da! Here's our beautiful parallelogram. These are way better lines than I could draw. All right, we're finding the area, right? Okay, let's recall the formula for area of a parallelogram. Here we go. Area is base times height. So we need the base and we need the height. All right. Let me get my pencil tool one more time. Area is base times height. So we know the base. The base is this many units long. And thankfully, it's on a grid mark so we can count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 units. Base is 18 units. So we just need to find the height. Oh, wow, look at this, you guys. We can just drop the height down. Of course, see, there's my straight line. And we can also get the units. 1, 2, 3, 4. Is that 5? Yep, 5. All right, we can just multiply. Is that 90? Let's see, 95. 18 times 5. 90. Okay, 90. 90 units squared. Oh my goodness. I saw these coordinates, and maybe you did too. You saw this coordinate plane, you thought you'd be doing a bunch of different calculations, but in reality, we just needed to know the formula and how to find the height, and everything we were able to count from the grid. So that's pretty cool. What is the area of this rhombus? Do not round any steps. All right, so let's recall the formula for area of a rhombus. You know, rhombus is really just a parallelogram. So base times height. Oh, where'd it go? So this one has the rhombus sketched, excuse me, and then see how this one is different from this one that we did, because this one was positioned nicely on those grid lines. This one is tilted a little bit, so we can't just count any of the side lengths. And it's also why we extended this to better see where that height is. You could have done it this way as well. So we'll use the distance formula to find the base. One of these, we can call this x1, y1, and x2, y2. Let's do that first. I'll write it up here. All right, let's plug it in. -1 minus -7. And then -6 minus -3. This becomes our positive, and we get 6 squared plus -3 squared. 6 squared is 36, and -3 squared is 9. This is 45, root 45. So our base is root 45. Now, you see how they extended the base here to find the height? Some people might think, well, can't we just do this to find the height? And technically you can, but you can see how it's not super accurate. Like we're not 100% sure where it's going to fall. It's not falling exactly on a coordinate point, so we couldn't use the distance formula. So that's why they've extended it for us and given an exact point. While a decimal, it's still okay. We're going to use those numbers to find this height. So we'll call this x2, y2. I want a different color because. All right. -4.6 minus -7. And then 1.8 minus -3. Wow. Let's get our calculator. I mean, you could do this by hand. It's not too bad because it's to the tenths. So -4.6 minus -7. -4.6 basically plus 7, right? So it's 2.4. And then 1.8, so that's 4.8, right? All right, 2.4 plus 4.8. 2.4 squared plus 4.8 squared. All right, 28.8. Okay, there's our height. Now, what are we trying to find? Area, base times height. So we have root 45 times root 28.8. Let's go to the calculator. By the way, when you log into your Desmos graphing, your scientific calculator is down here at the bottom. This is the one we used last year in algebra, so hopefully it feels familiar. This is the one you'll see on the SOL, so it's the one we want to use all year. Root 45. Come out of that radical, right? Oops, times root 28.8. Wow, it's 36, you guys. That's nice. Oop, here. 36 units squared. Okay, I hope that you found this helpful and useful. I know that perimeter and area is familiar, but it does get just a teensy bit more complicated when we add it to the coordinate plane and we start using the distance formula. We're also going to start using slope formula on the coordinate grid so we can look at parallel and perpendicular lines. That's coming up next week. I hope that you guys have a great weekend. If you're watching this before the weekend, you might be watching it after. In that case, I hope you had a great weekend. And just reach out if you guys need anything. I'll see you on Wednesday. Bye, everybody.